a variable line in a plane passes through a fixed point and meets the coordinate axes at points A and B, then the locus of the midpoint of AB is a hyperbola, parabola, circle or ellipse. This is from NEST 2019 Shift 1. Question 7. Right, let us draw the figure first. X-axis, y-axis. Suppose we choose that point to be somewhere here. Let us call it AB, or the coordinates A, B. Okay. Now, when they say that the line is variable, you have to understand that the slope of the line is variable. Okay. You have to understand that slope is variable, because if the line is passing through this point all the time, then the only possible thing about that line which can vary is the slope, right? So I can draw infinitely many lines like we do for rays of light from a point source, right? So let us show one such line. Let us show one such line which is intersecting the coordinate axes at points A and B. Okay. Let the coordinates be xa, 0 and 0, xp. Okay, 0, xp, and they want us to find the locus of the midpoint of AB. Now this is the midpoint M. Let its coordinates be xm, ym. Right. Now we can use the midpoint formula to obtain the coordinates of M in terms of xa and xp. So xa will be half of xa and ym will be half of, oh sorry, I should have taken this as yb, sorry, should have taken this as yb. So ym will be yb by 2. Got it? Ym will be yb by 2. Now we would like to find a relationship. We would like to find a relationship between the x coordinate of point M and y coordinate of point M. Now you tell me, how can we proceed? Of course we have to make use of the slope of this line. Okay, because that is not going to change, slope of AB. We can use two pairs of points to calculate the slope. First, okay, if I call this point as P, I can use the coordinates of P and A to calculate the slope, and I can also use the coordinates of P and B to calculate the slope. Correct? So if I use P and A, then it will be y2 minus y1, so B minus 0 upon A minus xa. Okay, so that is the slope. But this slope is also equal to what? Slope of the line PB. Okay, so what will be that? y2 minus y1 b minus yb upon x2 minus x1, so A. Now if you reach this step where we have used the fact that line's slope is always the same, no matter what 2 points you choose, okay, what 2 points you choose, then your job is almost done. What you have to do is, you have to now continue with these two ratios. Okay, you have to now continue with these two ratios, and then you can cross multiply to get AB equal to A minus XA into B minus YB, and then you can recall that XA is 2XM and YB is 2YM equal to A. Okay, and then if you want, you can simplify it further if you want, but I think this much is enough to come to a conclusion that it is a hyperbola. Now, why is it a hyperbola? Let's try to argue that, although we will not prove it entirely. Look, I told you xy equal to constant is a rectangular hyperbola, correct? Xy equal to constant is a rectangular hyperbola, or a hyperbola whose eccentricity is root 2, correct? Now, if we divide the whole equation here, if we divide the entire equation here by 4, then what are we getting? We will get xm minus a by 2, okay, xm minus a by 2 into ym minus b by 2 equal to ab by 4. Now if you shift the origin to a by 2 comma b by 2, okay, if you shift the origin there, then what will be your see, these will be your coordinates, right? X is equal to x plus h and y will be equal to y plus k. And if you do that, then this equation will change to capital X into capital Y equal to AB by, and that is hyperbola. Okay, understood? Raise your hands if you understood it.